Chapter 25 review. It's entitled The History of Life on Earth. Basically, it's a crash course in Earth history. Roman numeral 1 of our notes discusses the antiquity of life. Evidence suggests that the Earth is 4.6 billion years old. Life has been on Earth for most of that time. The oldest known living things go back about 3.5 billion years old. They are prokaryotes. And for approximately 2 billion years, prokaryotes were the only forms of life. Eukaryotes came a little later. Roman numeral 2 discusses the early Earth conditions and a model of the origin of life. Now your notes give you more details, you'll need to read through the notes, but the original atmosphere of the planet, evidence suggests based on ancient minerals, that the Earth was the atmosphere was reducing. That is, it did not have any free oxygen in it. It started off as an anaerobic atmosphere. So to have the abiotic origin of life does not involve a single event, but a series of events as prescribed by your book. First, there has to be the abiotic synthesis of organic stuff. In chapter 4, figure 4.2, it discusses the experiments of Stanley Miller. He indicated in the 1950s that it is possible under certain conditions to form simple organic molecules without living things making them. Now, the second step would be the abiotic synthesis of polymers. Now, in our cells, polymers are manufactured through dehydration synthesis. One of the ideas is that in the ancient environment that this could have been catalyzed by hot clay. And given that during those times there was no oxidation to break things down and there was no biodegradation to break things down, that these organic materials, small and large, could simply accumulate into what a lot of people like to refer to as primordial soup. Now, the third proposed step is that based on this complex chemistry, you have these membrane-enclosed pre-cells known as protobionts with chemical reactions inside being separated from the environment. Now, with the origin of heredity, the prevailing idea is known as the RNA first hypothesis, that the original genes were RNA, not DNA. DNA came later. Again, read your notes on why. Now, on the origin of eukaryotes really is discussing the origin of organelles. Now, we have the organelles of the endomembrane system, and we also have the mitochondria and chloroplast. The endomembrane system is thought to have first developed as an infolding of the outer membranes. That's known as the infolding hypothesis. After all, the endomembrane system still interacts with the outer plasma membrane. But mitochondria and chloroplasts aren't part of the system, so they are believed to have originated through what's called the endosymbiotic hypothesis, that mitochondria and chloroplasts used to be at one time living prokaryotes that were taken in and kept for their metabolic abilities. Roman numeral 4 discusses fossils. Now, a fossil is any remnant of an organism in the ancient past, which can include hard parts, bones, shells, teeth, impressions left in ancient muds, footprints, droppings, whatever. Now, ways to date rocks and fossils involve relative dating and absolute dating. With relative dating, geologists and paleontologists, paleontology is the study of fossils, are only concerned with relative ages, that is younger versus older, reconstructing the relative age of various geologic structures and index fossils. Absolute dating uses radiometric isotope techniques to apply an age in years. Read the notes concerning this on what I mean by radiometric, isotopes, half-life, and so forth. I'll finish this in the next section.